moving on to solving linear systems using Gaussian elimination. So just a quick recap of what we did. I showed you, or I gave you an introduction to what Gaussian elimination allows us to do. And then I said, in order to use the row operations that we use in Gaussian elimination, I need to show you the row echelon form and reduced row echelon form. Now that you've seen everything, we are at a stage where I can actually show you how to perform Gaussian elimination. So recall the original linear system that we had to solve, and here's it here. Okay, that's the linear system that we had, and then I showed you how to get it into an augmented matrix representation. There we go. How do we solve it? The big question. To solve the above system, we use the elementary row operations to transform the system into row echelon form. Okay, we're going to transform it into row echelon form. A note, it may be possible to transform it into reduced row echelon form. It may be possible, okay? The key word is may be. And you can solve it like that. But one, it's just much easier to get it into row echelon form, and it can be easily solved and it's less work. So get it into row echelon form. Note that the system can then be easily solved if it is in row echelon form, and that's best explained by me doing an example. So the technique to transform a matrix into row echelon form is as follows. Okay, you are going to obtain a leading one in a row if possible, and then you are going to create zeros below this leading one using the elementary row operations. And just recall what the elementary row operations are. We can interchange rows, we can multiply an entire row by a constant number that's not zero, and we can add a multiple of one row to another. And then you're going to repeat that same process for the next row. So you're basically going to try and get leading ones and get it into row echelon form. So that's enough talk. Let me show you how to do it using an example, and then you'll understand. So here's that very same system that we've been dealing with. How do you now solve it? Okay, so the first thing that I want to do, or the basic gist of Gaussian elimination, is to get leading ones in a row, in the first row, second row, third row. Let's deal with the first row. So how do I get a leading one in the first row using elementary row operations? Remember, I can swap rows, I can add multiples of a row to each other, or I can multiply them by constants. So what I'm going to do, the easiest thing would be to divide the first row by 2, sorry. So the new augmented matrix is going to be 1, 0, 1. I'm dividing this first row by 2, and then there's my vertical line, and I'll get a half. Okay, you can write it as decimals or fractions. I prefer decimals, but for this example, we'll use fractions. And then I'll leave the other ones as is. Okay, and that's how we get a leading one in the first row. Great, we're off to a great start. Now, just before I continue, I want to make something clear. When you're doing these elementary row operations, okay, someone may be checking your work or maybe marking it. It will be difficult to track. So to assist them, what I suggest you do is whenever you perform an elementary row operation, so for example, we did something to row 1, I want you to write row 1a, because this is the new row 1, is equal to, and what did we do? We halved the original row 1, so it's equal to half row 1, and just put it in line with the row that you performed it with. And then if you do another operation on row 1 later, you'll say row 1b is equal to, let's say you timed row 1a, this is row 1a, by 3. So you'll say 3 times row 1a. Okay, so that's what you can do. I am not going to do that right now when I'm doing these examples, because I'm going to explain what I'm doing, and just for the sake of space, I don't have a lot of space. So just remember to always annotate what you're doing. It makes it easy for someone to track, but I'm going to explain what we're doing. Okay, that's what we have there. Then the next part of the process is we want to create zeros below this leading one. So these must become zeros. How can I do that? Okay, well, what I can do is I can take row 2 and I can subtract 3 times row 1. So what I'll do is I'll take 3 times this, I'll times row 1 by 3. Okay, keep that in your head or write that on the side. And then I'll take row 2 and subtract what I had on the side. And it's much easier if you look at it like this. Okay, so I'm going to take 3 minus 3 times 1. Okay, so let's just write row 1 out as is. So I'm going to take 3 minus 3 times 1, that's going to be 0, minus 1, minus 3 times 0, that's going to be minus 1, 4, minus 3 times 1, that's going to be 1, and then I'm going to take 7 minus 3 times a half, that will be 5.5, but I'm going to write that as 11 over 2. Okay, and what I can also do is I can do a similar thing for the third row, but this time I'm going to take the third row and subtract 6 times row 1. So it's going to be 6 minus 6 times 1, that's 0. Can you see how I have these zeros below my leading 1? That's what I wanted. Then let's continue this. So it'll be 0 here. It'll be 1 minus 6 times 0, that's going to be 1. Minus 1 minus 6 times 1, that's minus 7. And then 0 minus 6 times a half, that is going to be minus 3. There we go. Okay, so that's what we have. Let's take this out and let's bring this to the top. Okay, now what we are going to do is I have a leading 1 in that row and I have zeros below it. Now I can go to the next row. So I want to create a leading 1 in this row. How am I going to do that? When I have a minus 1 here, let's multiply the second row by a negative number. So it's going to become, the first row we won't touch. That's done and dusted. We leave that one as is. Okay, I'm going to multiply row 2 by negative 1, so it'll be 0, 1, minus 1, and 11 over 2. Sorry, negative 11 over 2. There we go. And then what we need to do is we can leave the last row as is for now, doing it step by step. Okay, so there's my leading 1. Now what I need to do is I need to create a 0 below it because there's 0 on top of it already. So what are we going to do? What we can do is we can leave row 1 as is. We're not going to touch that again. Okay, I'm going to leave row 2 as is because it's got its leading 1. And for row 3, I'm going to take row 3 minus row 2. Why? Because this 1 minus that 1 will give me 0 in the new row 3. So it'll be 0 minus 0, that's 0. 1 minus 1, that's going to be 0. Minus 7 minus minus 1, that's minus 7 plus 1, that's minus 6. Minus 3 minus minus 11 over 2, that's going to be 2.5. Okay, so that will be 2.5 or 5 over 2. There we go. Okay, let's add another page. Okay, so there we go. We have the leading 1, and now we have a 0 above and below. Now I can move on to the next row, which is row 3, the final row. I need to create a leading 1. How am I going to do that? I am going to have to divide this entire row 3 by minus 6. If I do that, let's just do it here. I'll divide the minus 6 by minus 6, that will be 1. And then I'll divide the 5 over 2 by minus 6, that will be minus 5 over 12. And now let's check if we have row echelon form. I have leading 1s, okay? Any row with zeros are at the bottom. There isn't any row with zeros in this example. And the leading 1s, they all appear to the right of the leading 1s above them. Okay. Now we can see it is in row echelon form. Now that it's in row echelon form, how do we actually solve this? So if you look at row 3, we always start typically from the bottom and solve it upward. Okay, that's what we typically do. If you had to write this out in terms of the original linear system, remember this first column was all the x1 variables. This one was all the x2 variables. That one was the x3 variables. This line was an equal to sign. And this one are all the constants. So if I have to write out row 3 in terms of the linear system and its variables, it'll be 0x1 plus 0x2 plus 1x3 is equal to minus 5 over 12. And the 0x1 and 0x2 go away. So we have x3 is equal to minus 5 over 12. There we go. And then I want you to try it for the second row. if I had to write out the second row, it would be 0x1 plus 1x2 minus 1x3 is equal to minus 11 over 2. Okay, this disappears. Okay, we have x2. The x3, we know what it is. It's minus 5 over 12. So minus 5 over 12, that becomes plus 5 over 12. And we take it over onto the other side. Okay, x2 is equal to minus 11 over 2. But I'm going to write that as minus 66 over 12 because remember I'm dealing with a denominator of 12. And it will become minus 5 over 12. So x2 is now equal to minus 71 over 12. That's what x2 is. And I want you to try and solve it for the first row. So try the first row. And you will be solving for x1. So x1 is equal to, you will find that it's equal to 11 over 12. So let me just do the first row for you since it's the first example. It will be 1x1 plus 0x2 plus 1x3 is equal to half. The 0x2 disappears. We know what the x3 is. It's minus 5 over 12. Take that over to the other side. We're going to have x1 is equal to half plus 5 over 12, and that's equal to, let's check, 11 over 12. There we go. There are your answers. Okay, so there's your solution. That's how you solve this example. x3 is equal to minus 5 over 12. x2 is equal to minus 71 over 12, and x1 is equal to 11 over 12. And what I encourage you to do is take those values, insert it into your original linear system, and check if it actually satisfies them. Okay, it will satisfy it. That's how you use Gaussian elimination, much easier than the normal method of elimination and regular substitution. Okay, let's move on. So take a look at example 2. I want you to use Gaussian elimination to solve this linear system. All right, example 2. Let's use Gaussian elimination on it. So the first thing that we need to do is create a leading one in the first row, and we can do that by dividing the entire first row by 2. So it'll be 1, 1, 1, and 0 divided by 2 is 0. Let's leave the second and third row as is for now. Okay, so this is what we are going to have. Then we need to create zeros below that leading one in the first row. Okay, so we're not going to touch the first row. We've already got a leading one in it. Let's just copy it as is. Okay, now to the second row, how do I create, or how do I make that 0? What I can do is I can take the second row and add 2 times the first row. So it's going to be minus 2 plus 2 times 1, that's 0. It's going to be 5 plus 2 times 1, that's 7. 2 plus 2 times 1, that's 4. 1 plus 2 times 0, that's 1. This one, how do I make that 8 become 0? Well, I'll take 8 minus 8 times the first row. So it'll be 8 minus 8 times 1, that's 0. 1 minus 8 times 1, that's minus 7. 4 minus 8 times 1, that's minus 4. And minus 1 minus 8 times 0, that is minus 1. Okay, there we go. Now what we need to do is so we're done here. We created the leading one and zeros below it. Now what I need to do is move on to the second row and make that one. How do I do that? I just need to divide the second row by 7. So it's going to be 1, 1, 1, 0. Divide the second row by 7. It's going to be 0. 7 divided by 7 is 1. Then we'll have 4 over 7 and 1 over 7. Okay, and I need to make, and we'll get 0, minus 7, minus 4, and minus 1. Okay, let's add a page. Okay, then I need to make this 0. So what I'm going to do is I'm going to leave the first row as is. I'm going to leave the second row as is. And what I'm going to do is, to the third row, to make that 0, I'm going to add, so I'm going to take this and add 7 times the second row. Okay, so it'll be 0 plus 7 times 0, that's 0, minus 7 plus 7 times 1, that is 0, minus 4 plus 7 times 4 over 7. That's going to be minus 4 plus 4, 0. And minus 1 plus 7 times 1 over 7. That's minus 1 plus 1, 0. Okay, now this is a bit of a different situation because in the last row we have all zeros, and effectively what we'll have is 0x1 plus, so by the way, this is in row echelon form, that's why I'm solving it right now, plus 0x2 plus 0x3 is equal to 0. Okay, if this is the case, we're going to let one of the variables be a parameter, and what we do is we typically let it be that last variable at the end. So I'm going to let these disappear, and we're going to get 0x3 is equal to 0. That means I can choose any real number in place of x3 and it will satisfy this last equation. So we're going to say x3 is equal to t, and that's an element of R. Then we're going to working our way up. We're going to work with the second row. And if you had to write out the second row in terms of its variables, it would be 1 times x2. Remember, it's 0 times x1 here, so that x1 just falls away, plus 4 over 7 x3 is equal to 1 over 7, but we know that the x3 is t. So we can take the 4 over 7t over onto the other side, and we find that x2 is equal to 1 over 7 minus 4 over 7t. And then I'm sure you can solve what x1 is. Okay, so for x1, we are going to get x1 plus x2 plus x3 is equal to 0. So x1, and we know what x2 is, it's 1 over 7 minus 4 over 7t, and then x3 is t is equal to 0. Solve for x1. x1 is equal to minus 1 over 7, and then we are going to have minus 3 over 7t on the right hand side. So here are your solutions. Let me just take this working out. There we go. x3 is equal to t, where t is a parameter, it's a real number. x2 is equal to 1 over 7 minus 4 over 7t, and the next one is equal to minus 1 over 7 minus 3 over 7t. What I encourage you to do, and just to give you a level of practical understanding of this, is choose any real number you want for t and so this is a general solution, remember, in terms of a parameter. I want you to get a particular solution. So pick a number for t, get an actual x3 value. For example, pick x3 is t is equal to 3, x3 will be 3, and then solve what x2 and x1 are, and then go take those particular solutions and put it in your linear system. So write it out, put it in the linear system, and check if it actually solves it. Okay, that's exercise 2 covered.